Today we are going to discuss about Brester's law related to polarization. So, Brester's law. So, in 1811, the scientist David Brester performed a number of experiments on reflection to study the polarization due to reflection. So, first of all, we have to know the statement of Brester's law. He performed a number of experiments and concluded a law which is known as Brester's law. The law can be stated as when unpolarized light is incident on the refracting surface at an angle of incidence equal to polarizing angle, then the refractive index of that medium is numerically equal to tangent of polarizing angle. This is the statement. Mathematically, Brester's law can be represented as mu is equal to tan p, where mu is refractive index of the medium and this p is nothing but polarizing angle. In some books, the polarizing angle is denoted by letter IP. So, to know about Brester's law in detail, first of all, we must know what is polarizing angle, and then once again we will explain Brester's law. So, to understand what is polarizing angle, suppose xy is a refracting surface, and on this refracting surface, this surface separating two medium, this is medium 1 and this is medium 2. xy is the boundary. On this refracting surface xy, this is the symbol of unpolarized light. Then here we can say that unpolarized light is incident on a refracting surface xy. This is a normal young which is perpendicular to the surface xy. Then this angle is known as angle of incidence. This is angle of incidence. Then what happens when suppose this is the ray AB of unpolarized light, symbol itself says that this is unpolarized light. When this ray AB of unpolarized light is incident, making an angle of incidence R on the surface xy, then some part of the light or some of the light energy gets reflected. So, note this as ray BC, which is called reflected ray, and this angle is angle of reflection. And some part of the light energy gets refracted in this medium. Note this as ray B, which is again unpolarized light. Refracted light is also unpolarized. Then Brester found that the ray which is reflected, that is ray BC, is partially polarized, and the amount of polarization depends on this angle of incidence. He found that at certain angle of incidence, at particular angle or certain angle, when the ray is incident, then the reflected ray is completely polarized. That is, the vibrations which are parallel to surfaces are allowed, other vibrations are blocked. Therefore, this reflected ray is said to be completely polarized. When this ray is completely polarized, at that time this angle of incidence is called polarizing angle. So I is equal to P means at particular angle or at certain angle, the reflected ray is completely polarized. Such angle of incidence is nothing but it is called polarizing angle. So we can define polarizing angle as it is basically angle of incidence at which the reflected light or reflected ray of light is completely polarized. Then that angle of incidence is called as polarizing angle. This is the polarizing angle, and according to Preston's law, we have to prove the refractive index of this medium is equal to tangent of polarizing angle. So first, it is clear what is polarizing angle. Define polarizing angle. It can be defined as basically it is the angle of incidence at which, what is the condition? Reflected light is completely polarized. This is polarizing angle. So according to first law of reflection, angle I is equal to angle of F. As this angle is equal to P, therefore this is also P. This is angle of refraction. Angle NBT is angle of refraction. This is angle of reflection and this is angle of incidence. So next part, remaining part of this Preston's law, we will discuss in the next